Hello everyone. So in this video we are going to do something which is not from GTA. This is the question we have. The first question is a function f such that 0 to infinity to r be a differentiable function such that for all x greater than 0 the area bounded by the curve y is equal to fx, the x-axis and the vertical lines at x at 1 and x is given by this. So of course this is defined an area function. The students who have already learned the area under the curve, they know that this ft is considered to be the dummy variable, means t is considered to be a dummy variable, and the 1 to x indicates that we are finding the area of the function from under the curve ft from 1 to x. And it's called the area function because if you have any function like this and you are trying to draw the area, it is 1 to x, so as soon as x moves you are actually increasing the pieces of area into it, so you are trying to pile up all the area up to x. Now if the curve passes through the point e square comma e, which of the following statements is or are true? So all that we have to find out the function, what the function is embedded in this equation, we have to discover it. So you know the Leibniz rule of differentiation, that when we differentiate, so let me just define it or just show you what is this. So suppose I have two functions here, ux and vx, the functions of x, and there is a function ft dt, and if you want to differentiate it, of course you will get the derivative of the upper bound or upper limit, that is v dash x, and the value of the upper bound in the function minus the lower bound derivative and the value at the lower bound, that is ux. Now this difference will give you the differentiation of this whole thing. And why we are involving the differentiation? Because our target in this kind of question is to establish a differential equation. From there we can extract the function itself. So we will apply the Leibniz differentiation there. So what we get it here is the fx, because when you take this x and differentiate it, this will give you 1, and then again x you are substituting in the place of t by the rule, so it will give you fx. And the lower bound is 1, so derivative of 1 is 0, so of course this part is 0. So on the left hand side we got this, and we have to differentiate this thing, so we have half common and we are differentiating this thing, so x into f dash x minus fx, and the half derivative is, sorry, one derivative of 1 is going to be 0. So what I have done here, let me see, I have taken half common and x into fx is there, so I am applying the product rule there, so 1 will be there and that is not going to affect. So this is going to be our differential equation. From there we can say twice of fx is equal to x f dash x minus fx, and from there again how come minus fx? So plus fx, sorry, because we are applying the product rule. And we get this fx back here, so we get it fx is equal to x times f dash x. So now we will establish the integration, so we get f dash x by fx and dx, that is equal to 1 by x dx. Of course we will get it here log of fx, log of x, and plus constant term c. This constant term I can also replace with any log of k, and so we are getting the fx is equal to kx. Once we get this fx is equal to kx, I have to see what the things they have given. If the curve is passing through the point e square comma e, which of the following statement is true? So e square comma e means at the place of x we are substituting e square, so we are getting the value e. It means the f of e squared is equal to e. So what we get it here is f of e square is equal to k of e square It means the E is equal to k of E squared, and so k is equal to 1 by E. So I got the function back as fx is equal to 1 by ex. If I have the function achieved, we can now think of all the other options we given and we will see it. So the part A, the function fx satisfies the derivative equation x d f by dx fx square. Of course it is not so, because we have got this relation fx into x into f dash x. So the first part is incorrect. Now we go for the second part, the area of the region bounded by fx, the x-axis, the line x equals to 1 and x equals to e is e square minus 1 by 2e. So we have this function, and what the area they are asking is this one, that the function 1 by ex, and what are the lines they have given? The line is x equals to 1 to x equals to e. It means I have x equals to 1 to x equals to e dx. And so we will establish, we will integrate it. Already integration is established. So x squared by 2, and this is 1 to e. So we'll simplify by substituting this thing. So we get e squared by 2 minus 1 by 2. I can take their 1 by 2 common, and I will multiply this e there. So what I get it here is e square minus 1 by e, and so I'm getting e square minus 1 by 2e, and this is already given, so this is also not also, this is the correct choice we have. Now, so the third point is I have this one, the third option, the normal to the curve y is equal to fx at x equals to 1. So this is the line actually. The line is y is equal to 1 by ex. So let's try to understand what this means. 1 by e to the power, 1 by e into x. So when x equals to 0, that is going to be like this only. It means it's a line with a slope 1 by e. And when we put x equals to 1 there, I will get this point as 1 by e. 1 comma 1 by e is this point, and at any point where x equals to 1, you are actually drawing a normal. It is the same point actually you are drawing the normal for this curve. So basically this is not a curve at all. It is just a straight line, and suppose I have a straight line y is equal to 1 by ex, and you are the question is asking that we can draw the normal when x equals to 1. So this is the normal I have, and this normal is passing through 1 comma 1 by e or not. Yes, it is passing through 1 comma 1 by e. So is the question is actually given in the sense that just to discover the fx, and after that whatever comes in the way we have to think wisely. Now the part D is there. The part D is limit x tends to 0. I have 0 plus and e the power fx minus 1 by x perhaps. Yes. So we'll substitute it this thing there. Limit x tends to 0 plus e the power 1 by ex minus 1 by x. So this is the standard format of the limit. There's a k value is there. So e the power kx minus 1 by x is k. So this is going to be 1 by e. So B, C, D, all the options are correct for this question. Let's move to the next question. If you are in the context of area, and whenever you see this kind of situation, the y is equal to fx, and the x-axis and the vertical line t is equal to 1 to t is equal to x. This is the area function bounded by the curve given, and is a differentiable, and f1 is 1 by the way. So when t is equal to 1, t is equal to x given, you don't have to get confused. What we can think instead that that actually this is demanding the dummy variable. So one thing I can say, that this question, if you want to be very precise, then this can be written as y is equal to ft. But if any student who is doing area and you are only understanding that this question is coming from the area concept, you notice that this is t is equal to 1 to t is equal to x is going to be dummy variable for y is equal to ft. So why not we can think in this way, that ax is the area function already we have given. It means the ax now I can write in terms of integral, and we will equate with the given expression in terms of x. So what we can write it here is that t is equal to 1 to t is equal to x, and this is going to be ft dt. And when we find the area under this function f, I am getting the function of x k times x into fx. So if you are actually watching this video, I request you to pause this video wherever you want and try to understand the question and solve it by your own self. Then you simply unpause it and play it for the further solution. So what we can do here, that again we apply the same Leibniz differentiation both sides. So what we get here is fx as it is, and here we get the k times x f dash x plus fx. Now in this previous question we had there similar kind of situation, and the coefficient was half, and this minus half was given, but after differentiation it was not there present. So what we can write it here is fx is equal to kx f dash x and plus kfx. Now this is 1 minus k fx is equal to kx f dash x. We can write now f dash x by fx is equal to k times, not k times, k minus 1 by k, 1 by x, and this is going to be our integration establishment. So from there is one thing, this is going to be actually 1 minus k there. I have written there k minus 1. Of course, that's the mistake there, and this may pay later. So this is going to be 1 minus k by k. Now this is going to be log of fx and is equal to 1 minus k by k, and this is going to be log x, and plus c. Is already said that the f1 is equal to 1. When we substitute x equals to 1 there, that is going to be 0. There is also going to be 0, and therefore c is equal to 0. So our function is going to be fx, and you notice that this will jump off from here and go to the power x, and so we get x to the power 1 minus k by k. So this is the general function depending on the parameter k, and the values of k is given in each of the p, q, r, s options. So we are going to use it. So for the p part, I have k is equal to half. When we put k is equal to half, that will become half by half, so fx is equal to x. And in this case, the function is a straight line, which is given in the option number 2. And also when x approaches infinity, the fx should approach towards infinity. It is given there. For the option q, I have k is equal to 2 by 3. So for k is equal to 2 by 3, if you substitute it there, that will become 1 by 3 by 2 by 3. So that is going to be fx is equal to root x. If fx is equal to root x, you know the graph is going to be like this, but it is not going anywhere. Instead, it is going x tends to infinity when fx tends to infinity. So therefore option this is also correct. Now the r is going to be when k is equal to 2. When k is equal to 2, the fx is going to be 1 minus k, that is minus 1 by 2. So x to the minus 1 by 2, so 1 by root x. Really? If yes, so if this is there, so of course this k is equal to 2 is giving directly, there's one option there, the function satisfies fx is equal to 1 by root x. And when x is root fx is concave upward for all x greater than 1 or not, let's see. So if I have a 1 by root x graph, how does it look like? Is it concave up or not? So for that we can find the derivative of it. So f dash x is going to be, or maybe the reciprocal graph we can think. So I have the root x graph here like this, concave down, and what is happening when x equals to 0, the root x graph is starting from 0, but not 0, sorry, yeah 0, but I have to take the graph from x equals to 1. So what we do is, let's draw the graph of root x first for x greater than 1. So when x is equal to 1, the root x is also 1, so it was coming from here, but after that it will go like this, is root x. Now in order to draw the graph of reciprocal of the root x, what we will do that, because at 1 it is 1 and it at 0 it is 0, so from 0 it will start decreasing, and at 1 it will give the same value, so it will start because it was increasing, so it will also start decreasing because of reciprocal, and after that it will decrease. And you notice that when x tends to infinity, I'm not saying it's a symmetrical, it looks symmetrical, but moreover the symmetric schematic diagram is like this. So you can see it's actually the concave up for all the values starting from 1, or maybe for every real value. So this is concave up, so this is also correct one. Now the last one is when k is equal to minus 1. When you take k is equal to minus 1, that is going to be fx is equal to x to the power minus 2. Okay, so fx is equal to 1 by x square, and similarly 1 by x square graph is going to be like this, but I don't there's actually this part also, but this part is not taken. Why? Because x is greater than 1. So this is again the similar kind of diagram you will get, and it will also be the value concave up for that. So there's one thing I can add, then the option answer is 1 3 also. But why it is 1 also correct, that you see that 1 to infinity fx is finite value or not. So let's establish it. Let's see, I have 1 to infinity 1 by x square dx, and here minus 1 by x from 1 to infinity. Of course this will give you 0 minus 1, so that is going to be plus 1. I think it's correct. Okay. So these are the questions I wanted to share with you in this video, and there's a purpose behind it. I wanted to know, is there any mistake in this question, because I have created this question for some students, so I have already shared with you, so you can simply check whether any mistake is there or not. If it's there, then please write to me. So that's all for today's video. See you in the next video with other challenging questions. Till then, stay math active.